All right, let's go ahead and get started. Thank you everybody for attending today's webinar on how custom scripts can streamline your everyday tasks. This webinar is part of our Spatial IQ for Map Geo educational webinar series. We do these throughout the year on different topics that we find of interest to local governments. And if you ever have any ideas, please feel free to send them our way and we will do a webinar on any of those topics. Some logistics before we get started. Everybody is current in listen only mode. If there are any questions throughout this presentation, there is a Q&A and a chat box, which we will be monitoring. We will go over those at the end of this webinar. So don't have to hold your questions till the end. If you have something that you think of right away, go ahead and throw it in, but we will address it at the end of this webinar. And as always, these webinars are being recorded, so the recordings will be sent out in a few days. All right, let's do some speaker introductions. My name is Rebecca Davis. I'm a project manager here at Sanborn. As part of the App Geo division, I've been here for about 10 years, and I focus on local government and municipality projects, as well as some larger statewide initiatives as well. So I am joined today by my colleague, Ashley, if you want to introduce yourself.
Hi, everyone. I'm Ashley Tardif. I'm a data scientist here with the App Geo division. I've been with Sanborn for about 8 years now, doing ETL, data analysis, and generating visualizations to share various results. I've worked on multiple projects that include local government for parcel and utility management, as well as school redistricting and address management. And I'm always looking for ways to streamline our workflows and processes to produce accurate and results faster.
And I go to Ashley for all of my questions on that. So before we get into the good stuff, I just want to give some folks information about what our Spatial IQ for Map Geo program is. It is a managed services approach to scalable geospatial platform technologies. Our platform is Map Geo, which is an online data viewer, and Spatial IQ is the managed services side of that to help with any data maintenance, any data development, any analytics, those types of things. We are here to help, and that's what this program is aligned to do. As part of that program itself, you get geospatial data updates done on a cadence of your choice. We also have a GIS help desk support option. So if you have any questions while you're potentially doing some GIS work in-house, we're here to answer and help you out with those questions. We also have hosted downloadable data available on MapGeo, and that can be set to either be behind a login, so just town staff has access to that download, or it can be available to the public. Another part that we have is an annual overlay theme that we add onto MapGeo. This past year, we have added an alternative fueling stations, which you can see on the screenshot on the bottom right, which shows locations of different types of fueling stations. Primarily in this case, it's electric, but you have a couple other ones as well, like natural gas and propane. We also do annual strategic plans as well with local governments to help improve their GIS program, talk about any needs that they have, any projects that they can foresee coming in that upcoming year, and looking out farther than that as well. But we try to focus on the year coming up ahead and help them budget for some of those as needed projects that they have. And of course, these webinars are also part of this program. So today's topics, we're going to give a brief introduction of what scripting is, talk about some of the software that we primarily use for scripting, and then we'll get into the good stuff, which is some of our use cases. We have a couple different categories pulled out for some things for MapGeo related for our product. We also have master addressing table scripting and permitting, and then we have some extra larger projects that are a bit more multi-step in the workflow process. And then at the very end, we will go through some questions and answers. So Ashley, I'm going to pass this over to you.
So let's get into it and give a quick introduction as to why we script and the benefits for it. First off, it allows us to take tasks that we do every day, every week, every month, and make them into repeatable workflows. Scripting generally also allows us to keep intermediary steps or data in memory. So this means that we aren't taking up space on our machines or creating unnecessary files that we'll just have to delete later. We can do all of that processing we need on our inputs and then just produce a final output. It also allows us to more efficiently perform ETL processes. If you haven't heard this term before, that stands for extract, transform, and load. So we can extract our data from a database, folder, online, from anywhere really, transform that data for our needs, and then load it back into a database or into a folder, create a map, or other visualizations. Lastly, we want to highlight that scripting allows for hands-off processing. Once a script is created, we can just let it run without having to be involved in every step of the process. We can also set scripts up to run based on a scheduled time, which makes it even more hands-off. So some of the tools that we use primarily here at Sanborn include Python and R, which are coding solutions. We use various packages within these, such as Pandas, GeoPandas, and ArcPy. And both Python and R are open source and are great tools to implement on clients' machines if need be. We also use SQL, especially when we need to work directly in or with a database. Some non-code solutions include FME and Alteryx. These platforms both contain tools that you can drag and drop to create a workflow, similar to Model Builder if you've ever used that in ArcGIS. These are especially useful for exploring the data and analytical impacts as you're working on building your workflow.
All right. So before we get into the use cases, we wanted to hear from you guys to see who has ever written their own custom script before to automate different tasks. And if so, what types of scripts have you done? So I'm going to launch our first poll. Oops. Come on, computer. Poll launch. All right. You guys should all have a pop-up on your screen. And if you can just give some answers to those, that would be great. All right, we're holding strong at about 70%, so a couple more that coming through. I think the results are kind of what I had expected, so I'm going to end this poll and I will share the results so we can all take a look at those. So we have about 11% that says yes, they're already doing some of their own scripting and they're a wizard at it. We have others that have done a little bit, nothing super complex, and then no, they've done absolutely nothing, and that's what we're here for. Looking at some of the answers that we got, let's see, SQL updates, some Python coding, creating a file geodatabase from an ArcPro project. So these are some great answers. A nightly database compress. So great to hear. So hopefully you guys enjoy the use cases that we have today, and we'll get back to it. All right, back to you, Ashley.
Yeah, so let's go ahead and jump right in. As some of you might know, we have a tool called the CAMA Uploader. This is a script that updates the CAMA data from the assessor's database onto MapGeo nightly. And it also has another use, which is to upload essential, spatial, and tabular data. This can include parcels, utility data, zoning, annotation, just to name a few examples. However, in order to upload that data to MapGeo, we need a process that will read the data directly from the city's database and convert it for use on MapGeo. Now, this is where scripting comes in. By scripting this process, we can keep the data on MapGeo up to date throughout the year. We can also remove the chances of error by connecting directly to the city's database, thus eliminating the need for copying and sending data across. In a script, the conversion process is also streamlined and made repeatable. And this means it can convert multiple data sets quickly without the need to manually convert each data set. It's hands-off, which is great. The uploader then reads in the folder with the converted data and uploads it to MapGeo, making for seamless integration. So let's get into the weeds a little bit. How exactly does this process work? Well, we've created a Python script that lives on the client's machine with the city's database. Usually, if they have the CAMA uploader, it also hosts the assessor's database. This script reads in the required data from the city's database and then converts the data for use in web mapping. This is typically a GeoJSON file, or we can sometimes do some other conversion processes in here if needed. A task scheduler is then set up that will run the script nightly and update the data using the uploader to MapGeo. This way, all of your essential data is always up to date on MapGeo and in line with your in-house data. This next slide presents something a little similar. It's also using Python, except the code is slightly different because it pulls data from an ArcGIS online feature service to upload to MapGeo. This is beneficial if the data is stored and updated in ArcGIS Online, and if the client wants to bypass having a script on their own machine. And while MapGeo can read in feature services directly, this script is helpful if the client wants the same data set, but different styling or features to be shown on MapGeo than what is shown in ArcGIS Online. The MapGeo uploader can be taken a step further in this next example. Our client needed the Acela application to be updated with property and parcel data whenever the assessor's data and MapGeo was updated. Therefore, we wrote a script that keeps the data on Acela up to date and in sync with the assessor's database and MapGeo throughout the year. It connects directly to the MapGeo database, which is already being updated regularly thanks to the uploader script. It then automatically updates the ArcGIS Online web map used in the Acela application. This allows for hands-off processing and seamless integration. So how exactly does this work? Well, it's a Python script again that reads both the property and parcel data from the MapGeo database. It then joins the data sets together and creates a GeoJSON. It also generates points from the parcel data for an additional GeoJSON that can be used for the CAMA data in Acela. Both GeoJSONs are then uploaded to ArcGIS Online, where they overwrite the existing GeoJSONs and thus update the web map and application. I know we're flying through these a little bit. We're gonna move on from MapGeo and get into some master address tables. So here we were tasked with creating a comprehensive address database with owner information to permit integration with OpenGov. For this task, we decided to script the process because it streamlines the update process whenever a new address is added or owner information is updated. It reduces the time needed to update the dataset. It provides dates of change to the records to allow for historical record keeping and identify when addresses changed. It also provides seamless integration with OpenGov by always outputting data in the required schema and file format. So this one's a little different than what we looked at before because we're using FME here. It's a process that compares state address points with the assessor's table to fill in gaps, remove duplicates, and capture owner information. It then formats the data into the required standardized schema. Whenever new addresses are added or owner information changes, we go ahead and rerun this script, and then it updates the master address table so that OpenGov can receive the most up-to-date information.
And I will make one comment in here as well that we have several clients that do have a master address table that we have scripts running for. So this is repeatable, not just for one client, but for multiple different clients. We know that this is a hot topic that's coming through, particularly in the state of Massachusetts, but certainly everywhere else needs to have those master addresses as well. So
yeah, so exactly. Another thing that's really great about this is we can go ahead, use this, tweak a couple of things, and it's ready to go for another town.
Yep, just format it for their data and their inputs, and it's simple to go. All right.
Now, we had another request come in that was also related to OpenGov. The client here needed a way to bulk import permit information from OpenGov back to the assessor's database so that the assessor didn't have to input each new permit record manually. The benefits of scripting here include that this process eliminates the need for manual entry of individual records, which saves time and effort spent by the assessor. The script also merges multiple files into a singular file without the need to manually merge the files. And it provides seamless integration with Vision by following the requirements for the standard building permit import process. So this one again is back to Python. Permit records are manually downloaded and stored in a folder. So when the Python script is run, it reads the data in that folder and merges the permit records into a singular table. The script reads the master address table from OpenGov to pull in the required CAMA ID for Vision and assign it to the correct permit records, and then formats the data into the standardized schema required by Vision before finally outputting a file in the required format. The assessor then takes this output and uploads it to Vision using the standard building permit import process. Now, while this process is not entirely hands-off, we did write documentation and then wrap the Python code and command line that includes user arguments for easy and repeatable use. There was 1 month where the town had almost 300 permit records to import. This process only took a few minutes, whereas in the past, the assessor used to have to spend hours each week manually searching for the record in Vision and then importing it. Next, we're going to move on to something a little bit different again and get into our multi-step workflows. So I want to touch on school redistricting a little bit. First, though, why school redistricting? Sometimes we get that question a lot. Sometimes a town or city has to reconfigure their school districts. This can be due to a school closure, a new school being opened, grade configuration changes. So if an elementary goes from K to 5 to K to 4 or vice versa. Redistricting may also be needed if there is an overall increase or decrease in the student population, or if there is just a need to rebalance demographics across the district. There's sometimes a lot more reasons, but those are the ones we frequently come across. Now, this overall process, we need student data as well as a current school district polygon layer or street list. We then geocode the student data based on their address to get a sense of where the students live in the town. From there, we create components or building blocks, which are essentially neighborhoods that we can move around and shift from one district to another. These components contain a summary of the student data that live in those areas. Once we have a configuration of components that looks good and meets the guiding principles of the project, we present the scenarios to the project committee and discuss the pros, cons, and any changes we might need to make. Then we usually go through several revision steps where we repeat the scenario conversion process. So I want to touch on how scripting helps us here. And as you can see over on the right-hand side, this is actually an Alteryx process. And where scripting is super beneficial for us is that we can automate our statistic and summary workflows for how we apply student data to components and district scenarios. These workflows are also repeatable and can be used for different towns and cities. Again, going back to that, just tweaking a few components and inputs. By scripting this process, it's also easier and more efficient to explore various options. So a town may be undecided on how they want to move forward with redistricting and need to review what happens if they close one school or if they close a different school. If they need to have one school be converted to an elementary school, which one do they choose? We can build these options into one script rather than having to make multiple processes to account for any given number of configurations. Lastly, we found that there are always moving pieces in these projects and changes need to be made as we explore scenarios and scripting, therefore allows for faster updates when things need to change. So we don't have to start at the beginning, but rather can change one or two inputs and then rerun our scripts. So with all that being said, I'm going to pass it on to Rebecca and she'll go through a few more use cases.
Awesome. Thanks, Ashley. Yeah, we're definitely getting into some of the more complex scripting and processes that we have for some of our clients. So the next one that I'm going to talk about is West Hartford's data transfer. So the need that they have here is kind of twofold. So they need to keep their MapGeo data up to date with the latest CAMA and assessor's database information, as well as the clerk's database. The second part to that is keeping their addresses up to date using their address tool, which was custom built by the AppGeo division many years ago, and is still being used today. But the use for that was that when a new parcel had been created and subdivided and a new address had been provided and assigned, the building department needed to be able to have that address almost immediately in order for them to be able to pull permits to start working on that. So the address tool is helping them with that part of the process, and then it's bringing in some of that other information. So the components that are needed for this transfer are the assessor's data, the clerk's data, the MapGeo web viewer itself, and all of the data that is on there, the address tool application, and then finally getting back to that permitting application. So let's take a look at how this works. So starting on the left-hand side, we have our two authoritative data sets for the assessor's database, which is pulling in all of the property information with the property ID, the CAMA ID, any of the values and assessments, as well as owner information. But for the town of West Hartford, their clerk's data is what keeps the ownership most up to date. So the clerk's owner information is essentially overriding the assessor's database through that scripting process that you see there before it makes its way to our hosted SQL database. This database is where everything is collected and gathered, and the outputs from those scripts are putting it into the format that we need for our various applications. Moving over to the right-hand side where we have MapGeo, so all of our data in that SQL server, again, that's the spatial and the tabular data. So all of that data is getting pushed to MapGeo. That is being done for a nightly basis. So MapGeo is kept up to date, so that fulfills their need for that number one bullet that we had. And then looking at the address application, you can see that the arrow is going in both directions from the SQL database to the application. and vice versa. So any information that is added into that application by town staff is getting back into that SQL server and eventually is making its way to the permitting application. In the addressing application, there are more scripts built within that in terms of permissions and roles and who has access to add and create new address points and edit any further attributes and information in there before it officially gets approved. So being able to have those different roles and permissions within the addressing application is what is allowing us to create the initial address point to be able to have it for the permitting database itself. So they're able to pull that building permit as soon as they have that address available. All right. And then moving on to the next one, the state of North Dakota has a parcel program, and we've been working with them for many years now to be able to maintain a comprehensive statewide and parcel and tax roll so that they're not into the CAMA system as much up there as we are here in New England. But their tax roll data is essentially the same thing. It has your values, it has your ID, it has your owners, and all of that information. So by creating a script, we're able to maintain 53 different counties parcel and tax roll data. So if you think about it, that's really 106 different data sets that we need to bring in various formats, whether it's being hosted somewhere, it's being maintained and is living on the client and the county's server somewhere, or if it's being maintained by a vendor. So we need to account for all of these different types of situations. So um, in the next slide, I'll kind of show kind of how that works, but the script has been beneficial for us where we are pretty much all hands off. There's very little that we need to intervene with it once everything was set up. So it's trying to look at all of that data that's coming in, it's bringing it out and putting it into the format that we need at the statewide level for a comprehensive data set. And all of that gets pushed to our parcel viewer that the state has. So looking at how it works, I know this is super simple and what I'm talking about is quite complex, but this is just one small piece of what this automation is actually doing. So for the state of North Dakota, excuse me, we are using FME, which is now FME Flow. It was formerly known as FME Server, so that's just saying that it's living on their own server. It's pulling in different workbenches for the data that is coming in. So what this is doing is allowing us to trigger multiple sequential workflows on a schedule and monitor the folder for any new and updated files that have been submitted, and then sending out updates via email. So again, that's super layman's terms and super basic, but essentially what this is doing is you have your inputs of the parcel and the tax roll data. The script is then looking at that data, reviewing it for completeness to ensure that we have the required fields that are needed. It is then taking the original input schema, putting it into the statewide dataset schema, running it through that process for various validations before it essentially is a successful upload. For that successful upload, the counties receive a success email saying that your data that has been submitted has successfully been implemented into the statewide database. If anything fails, that comes to our team and we need to go in and see what happens. The most common issues that we see is that either the county has had some staff turnover, so the data that we are receiving for the most recent upload is either in a different format, has a new field, a different schema, things like that are the most common issues that we're seeing that are getting flagged. Something else that's happening behind the scenes for all of those emails is we have a master spreadsheet where all of those emails are looking to see, okay, if it's from county A, these are the people that need to be sent an email for that success. So to maintain the emails, to maintain that spreadsheet and have everything talk to each other has been super efficient. No emails are being sent out manually. It is all being done through this script, which is super helpful. So what does this all look like? So I said, obviously, the statewide parcel viewer, they also give us different attributions, and we were able to use those to create different reports and visualizations. One of the visualizations that we have is a status report of the data refresh. So here we're looking at the tax roll status to see when folks have last updated and if they're within spec. So what I mean by saying spec is that we have another spreadsheet in a database living internally that says, okay, we expect county A to submit their data the first of every month. So if they miss that date, they're going to be considered out of spec. So depending on the frequency and the cadence of the uploads of each county, that is where the status maps are coming into play. Another validation report that we get from this is to flag any of the invalid geometries. We also have a what we call is a mismatch report showing any parcels that do not match to a tax roll record and vice versa. And we also are able to show parcels based on their last update date, again, which is what is feeding the status map. And all of those, the mismatch reports all are available online for the counties to view and see, so they're able to resolve some of those mismatches to help them have a more comprehensive data set and more accurate data. The next one is for the city of Oklahoma City to create a flood data management tool. So this tool is used as a platform to allow decision makers to accurately assess flood risk potential across the city. So some reasons why we chose to script these processes is to fuse multiple data sources into a custom risk assessment, allow for new and updated data to be added into the tool. So you're able to essentially rerun the script with that updated data. And there's little to no coding necessary for this tool once it's built. There are a couple of manual steps that are required, and similar to what Ashley had said, there is documentation that has been provided to the client, so they're able to maintain that and update that going forward as they need to. Additionally, enhancements can easily be made to the FME workflow. Again, similar to what Ashley said, if there's something that changes mid-process, it's super easy just to make one simple little change in the middle of that, and it's not going to disturb anything else in that process, and it just smoothly integrates with each other. So how does this all work? Again, I always call these spaghetti diagrams because it's just a bunch of lines and some meatballs in the mix. But essentially what this is doing, it's taking your input source data, which are in this case your roads, your buildings, your drainage basins, and and other depth rasters and features like that. It's pulling all of that into and looking at our flood risk scoring criteria, which is saying if a building is in this depth of a flood raster, it receives a score of 5, for example. So it's looking at those different criteria. It's taking those inputs and giving it a risk score. All of that gets totaled up into our sub basins themselves. And the FME script in this case was using FME, but through the Esri data interoperability extension. This is allowing it to be configured in FME using that language, and it's also able to easily be passed over to the client once the data is complete from our end in terms of building everything, and then it is passed over to the client, and they are able to use the data interoperability extension to make any edits and enhancements going forward. So for this one, we're going to take a look at what it looks like as well. So here we are showing our flood risk score index at the sub-basin level. You're able to see those 3 highest sub-basins that have the highest scoring index based on the flooding potential. For these, we did normalize our scale in terms of the index score, just so it was easier to understand and see at a high level for a visual of what basins are at each score index value. So then taking a little bit deeper of a dive, looking into our likelihood of the building flood risk, we are seeing here that we have our raster files, which is the blue squigglies, and you have your buildings in different shades of colors of red varying down to yellow for the least amount of flooding likely to occur. All right, so that covers all of our use cases. I know that that was a lot of information. We hope something came out of that, but now we want to hear from you guys again to see what are some other needs that you guys have for processes on what could be automated. So I'm going to launch our second poll. And I'll give you guys a few minutes to submit your answers for that. While we are getting responses in, we're just going to give a quick wrap up and then we'll review all of the comments afterwards. So I have too much open on my screen. Just to give a quick wrap up, scripting is beneficial for any of these tasks. If you have something that is repeatable, you want to streamline a process, you want to be more hands off on what is needed from you to complete your task. You want to connect to any existing databases and incorporate that into any existing workflows that you may already have to make your time, your valuable time, saved so you can do more and get more done while your script does all of the hard work for you. All right. So, with that, let's see what we've gotten for some audience responses. We've still got a couple coming in, but let's see. Give you guys another minute to fill those out. I know it's a fill in the blank one, so. All right, we're holding steady. So I'm going to end the poll so we can take a look at the responses. All right, let's see. Some of our responses include some data cleanup, removing some spelling errors and different things like that, utility line edits, updating addresses, updated web servers and applications, tax parcel updates, update multiple applications and portal permits, which is awesome to hear. Let's scroll down. We have real estate data to update tax parcel data. So any new owners that change of address, etc., those all get updated and shown. Updated crash and collision data from the Department of Transportation. And processing county assessor data, updating master address point, spatial layer, and department address database. So those are awesome to hear. And we always encourage if you ever have any questions or any ideas and things that you think could be scripted, but you don't know how to do that, that's what we're here for. So if you have any questions, you want to just talk and brainstorm some ideas that you have on what potentially could be scripted to help you out, we're always here. Our contact information is there. Again, these webinars are being recorded, so the recording will be sent out sometime next week. It'll be up on our library. And I want to say happy spring because today is the first day of spring. So, Ashley, do you have anything else you want to add?
We do have one question in our Q&A,
Yes.
which is just, does or can the master address script integrate with EP and L, which was formerly Energov Tyler product? I am not directly familiar with those. I know we've worked with Tyler in the past. I want to say that is most likely possible. It's just a matter of communicating about what the needs are and then going ahead and seeing what we can do.
Yeah, absolutely. I assume it's probably some similar to what we have for
Yeah.
OpenGov. We know all products are a little bit different, but essentially we can figure out something for that. All right, we'll stay on for another minute or so if anybody has any final questions. But again, we want to thank you all for joining today's webinar and hope you have a great rest of your day. All right. Thank you, guys.
Thank you, everyone.